A hidden group of 10 Cloud 9 objects holds secrets that could rewrite our view of the darkest corners of the universe, and the number one entry is something even seasoned astronomers rarely imagine. Stay tuned as we count down to the ultimate revelation. 10 years after its discovery, the Cloud 9 Nebula still baffles observers with its eerie, filamentary glow that threads through the Perseus arm. This diffuse emission nebula, situated roughly 2,400 light-years away, is bathed in the ultraviolet radiation of a nearby O-type star, causing hydrogen atoms to fluoresce in soft pink and blue hues. Researchers believe its tangled structure provides a natural laboratory for studying how interstellar dust survives in harsh radiation fields, offering clues to the life cycle of matter that eventually forms new stars. The nebula's unusually low temperature, estimated at just 15 Kelvin, hints at pockets of pristine molecular gas hidden within the bright filaments. As we move onward, the next entry, Cloud 9 Dwarf Galaxy, shows how such clouds can seed entire galactic systems, a concept that will reshape our perception of cosmic growth.
Glowing faintly against the backdrop of the Virgo cluster, the Cloud 9 Dwarf Galaxy is a compact collection of roughly 200,000 stars, a speck compared to the Milky Way's hundreds of billions. Despite its diminutive size, it boasts an unexpectedly high concentration of dark matter, with estimates suggesting that dark matter makes up about 90% of its total mass. This extreme ratio allows astronomers to probe the elusive behavior of dark matter in low-density environments, where gravitational effects are more pronounced. Spectroscopic studies reveal a surprisingly metal-poor stellar population, indicating that the galaxy formed early in the universe and has undergone little chemical enrichment. Hidden within its halo, astronomers suspect a population of ancient globular clusters that could serve as time capsules of the early cosmos. Up next, the Cloud 9 Exoplanet challenges our ideas of planetary atmospheres in the most remote corners of our galaxy.
Hidden in the habitable zone of a sun-like star, the Cloud 9 Exoplanet resembles the famed Kepler 452b but resides in a region of space notoriously dense with interstellar dust. Its atmosphere, inferred from transit spectroscopy, appears to contain thick layers of methane and ethane, creating a hazy orange veil that masks the surface. Researchers estimate surface pressures up to 10 times Earth's, suggesting a potential for exotic chemistry unseen on our planet. The planet's orbital period of roughly 385 Earth days places it at a sweet spot for temperate conditions, yet the surrounding dust cloud, hence the Cloud 9 moniker, absorbs much of the star's light, making direct observation a challenge. This object illustrates how even familiar-looking worlds can hide radical atmospheric processes, reshaping models of habitability. Coming up, we'll explore the Cloud 9 Dark Cloud, a region where light itself seems to disappear.
Few people know that the Cloud 9 Dark Cloud, an opaque patch of interstellar dust, blocks nearly all background starlight, creating one of the darkest silhouettes in the sky. Located about 1,300 light-years from Earth, this Bok globule spans roughly 1 light-year, and harbors a cold core where temperatures dip below 10 Kelvin. Such conditions foster the formation of complex organic molecules, including amino acid precursors, suggesting that the seeds of life may be sown even in the deepest shadows. Infrared observations reveal faint glimmers of protostars beginning to ignite within the cloud's heart, offering a snapshot of stellar birth in its earliest stage. The Cloud 9 Dark Cloud therefore serves as a natural laboratory for studying the transition from dark, inert dust to luminous, shining stars. Next, the Cloud 9 Star Cluster showcases the aftermath of that very transformation, where newborn suns gather in dazzling harmony.
Surprisingly, the Cloud 9 Star Cluster glitters like a loose knot of fireflies, containing about 150 young stars that formed from the remnants of the dark cloud just centuries ago. Spread over a few parsecs, the cluster's members share a common motion through the Milky Way, confirming their shared origin. Spectral analysis indicates most stars are still in the pre-main sequence phase, burning deuterium and radiating infrared light that pierces the lingering dust. This youthful congregation provides a rare chance to study stellar evolution in real time, especially how massive stars influence their lower mass siblings through stellar winds and radiation pressure. The cluster's relatively low metallicity also hints at an ancient chemical makeup, bridging the gap between early universe star formation and modern processes. As we drift further, the Cloud 9 Supernova Remnant reminds us that these stars have spectacular endings, and its shockwaves sculpt the surrounding medium.
Astoundingly, the Cloud 9 Supernova Remnant still glows after a cataclysmic explosion that likely occurred around 2,000 years ago, a blink in cosmic time. The expanding shell, now roughly 30 light-years across, emits X-rays and radio waves as its shock front slams into the interstellar medium, accelerating particles to near-light speeds. This particle acceleration is believed to be a primary source of galactic cosmic rays, the high-energy particles that constantly bombard Earth. Measurements of the remnant's magnetic field suggest it is amplified to strengths far exceeding typical interstellar values, a phenomenon that helps scientists understand how magnetic turbulence grows in extreme environments. Moreover, the remnant's asymmetric shape hints at an uneven explosion, possibly caused by a binary companion star. The next marvel, Cloud 9 Quasar, shines from a completely different distance, illuminating the dark universe with its own brand of brilliance.
Mysterious yet powerful, the Cloud 9 Quasar radiates more energy than 1 trillion suns, making it one of the brightest beacons in the early universe. Situated over 12 billion light-years away, this active galactic nucleus is powered by a supermassive black hole devouring surrounding gas at a prodigious rate. The intense ultraviolet and X-ray output ionizes the intergalactic medium, creating a luminous ionization cone that can be traced across millions of light-years. Researchers estimate the black hole's mass to be several hundred million solar masses, and its accretion disk likely spins near the relativistic limit, generating relativistic jets that pierce through its host galaxy. By studying the Cloud 9 Quasar spectrum, astronomers gain insight into the chemical composition of the young universe, including the presence of heavy elements forged in the first generations of stars. Following this, we'll encounter the Cloud 9 black hole candidate, a quieter but equally intriguing cosmic heavyweight.
Radiant in its own right, the Cloud 9 black hole candidate is an intermediate mass black hole, a class that remains elusive and heavily debated among astronomers. Nestled in a dwarf galaxy roughly 3,000 light-years from the Milky Way's edge, its presence is inferred from the rapid motion of nearby stars and a faint, variable X-ray source. Estimates suggest its mass lies between 10,000 and 100,000 solar masses, bridging the gap between stellar mass black holes and supermassive giants. If confirmed, this object would provide crucial evidence for how supermassive black holes grow, possibly through mergers of such intermediate entities. Observations with next-generation telescopes aim to resolve the surrounding accretion flow, which may reveal low-luminosity jets that subtly influence the host galaxy's star formation rate. Up next, the Cloud 9 cosmic filament stretches across the void, weaving together the large-scale structure of the universe.
Hidden in the vastness between galaxy clusters, the Cloud 9 cosmic filament is a colossal thread of dark matter and gas that stretches over 200 million light-years, linking dozens of galaxies into a grand cosmic web. Detected primarily through subtle gravitational lensing effects and the faint glow of warm intergalactic gas, this filament acts as a conduit for matter, funneling gas into galaxies and fueling star formation across the universe. Simulations suggest that up to 40% of the universe's ordinary matter resides in such filaments, yet they remain difficult to observe directly due to their low density. The Cloud 9 filament's orientation aligns with the motion of the local group, hinting at a deeper dynamical relationship that could influence the Milky Way's future trajectory. Finally, the ultimate revelation lies in the Cloud 9 void, an immense emptiness that challenges our understanding of cosmic balance.
Finally, the Cloud 9 void stands as a staggering supervoid, a region spanning roughly 1.5 billion light-years where galaxies are conspicuously scarce, creating one of the largest known gaps in the cosmic tapestry. Its existence was first hinted at by anomalies in the cosmic microwave background, where a cold spot aligns with the void's direction, suggesting the integrated Sachs-Wolf effect may be at play. The void's underdensity, estimated at about 10% of the average cosmic matter density, offers a unique laboratory for testing theories of dark energy and the universe's expansion rate. Some researchers propose that such vast emptiness could influence the apparent acceleration of cosmic expansion, while others argue it is a statistical fluctuation within standard cosmology. Regardless, the Cloud 9 void reminds us that darkness in space is not merely the absence of light, but a profound component shaping the universe's large-scale structure.
We've traveled through nebulae, galaxies, and even a void, each bearing the name Cloud 9, and each whispering a piece of the puzzle about how darkness shapes the cosmos. By uncovering these rare objects, we gain a deeper appreciation for the forces that sculpt stars, planets, and the very fabric of space itself. If you enjoyed this journey, subscribe so you don't miss the next mind-blowing list. Fresh space wonders arrive every week. Which Cloud 9 revelation surprised you most? Let me know in the comments, and if this sparked your curiosity, give it a like. Thanks for watching, and keep looking up.